Hey, I hope you're not too tired. So, I'm about to expose in 8 minutes what we did in 3 years regarding the how we use all these components developed in the context of FAIRC or for EOSC for the community of mathematicians. Because we at ZBMath and SGMath we represent the mathematician writing articles and software. So, to make it short, I already presented a bit this morning. So the AirSAC we sorry, I'm going a bit fast. We are exposing software and collecting metadata on software for mathematicians. We collect we give them identifiers. We curate metadata by hand on research software. And so in this context, for the mathematician, we want them to be able to use proper identifier for the source code, and also to have the source code in a very a source code that they can find in a very safe place, which is named software heritage. So, in this context, we have archived 15,000 software that are mostly used by mathematicians. I'm confusing. Yeah. Also regarding software, we are also exposing our metadata in standard for the community that is named code meta. And this software are exposed in the in a framework we call the deposit workflow, and we deposit this metadata at software heritage. And also the last part of this work is to expose the software in a citable manner, and so mathematicians can use the citation features we have built in the context of the AirSAC work. So that's certainly one of the most interesting part of this work we achieved these last years is the integration with the PID graph and the RD graph. So you already know these components since today. And what we are doing is that we want us, ZBMath and SGMath, as an aggregator for mathematicians. We aggregate metadata for articles and software. We want this metadata to be findable in other services, like the site, like OpenAir, and in this context, we work to expose these entities in other services. So we produced two different work. One with DataSite to expose the authors we have that have a ZBMath identifier. We have that for authors, and to match it with the ORCIDs, we could find a DataSite. We did the same with the DOIs. We collect a lot of DOIs, and we found a common matching with DataSite. And so this is mostly what we will expose in DataSite, more than 2.5 million of articles metadata in the domain of math. And on the side of the RD graph, we also we have more freedom, if I can say, because we can expose our own identifier into the RD graph. So we will expose more than 4 million of articles metadata in the RD graph. Also, we also plan to expose software metadata. So what we do with code meta to expose them, to deposit them at software heritage, we mostly do the same work with the RD graph. So that's what I wanted to talk. And now the PDMR integration. So the PDMR, now you know what it is because all of you were very attentive to the previous presentation of what is a PDMR. So this is a component to resolve persistent identifiers. And us, and ZBMath, we have our own identifiers for authors, for software, for articles, and we want this identifier to be considered as PIDs. And so this is how we partners with GVDG to expose our identifier into the PDMR. So typically a mathematician that is finding a software, it will find a suite typically, and the suite, which is this identifier of software heritage, it can be resolved with the PDMR, and it is exactly the same for the article identifier. So here, typically, you have an identifier which starts with ZBL, which is the root, the prefix of our identifier, and when we click on that, we can copy it and pass it into the PDMR, and we can resolve it. So that's how I wanted to expose to you the benefits of, I mean, not everything, but the main aspect of our progress. Also, our work covered also the DTR, because in the mathematics we have our own knowledge graph for mathematicians. We call it the mathematics subject classification. It is a classification we are currently exposing into the DTR. So, and the last element I didn't talk about, but I will further talk about is the next panel discussion on interoperability is the MSCR. All the mapping we built for the PID graph, for the RD graph, for AirSAC, all these mappings will be available into the MSCR.